You've seen this before, solving quadratics. Look at all these different ways to solve quadratics. The star of the show today is solving by square roots. Because you're such a pro at solving regular equations back from the good old semester one in your pre-algebra days, this isn't going to be much of a change. Here I have an equation and I'm trying to solve for x. Now normally you say, hey, I need to get x by itself. Well, in a case like this, we're going to say we need to begin by getting x squared by itself. So I need x squared by itself, which means I need to get rid of the minus 5, which you know means plus 5. So I get x squared equals 16. So I've gotten the x squared by itself. Now I need to square root, because the square root is the enemy of the squared. Just like addition defeats subtraction, multiplication defeats division, square rooting defeats or is the inverse operation of x squared. So I'm going to square root both sides, and when I do that, the square root of x squared ends up being an x. The square root of a 16, you say means 4, but I'm going to show you something surprising. It's plus or minus 4. What the heck is going on there? Well, let's get back to that in a moment. As I went through this, these are the 3 steps that you're going to need to solve your square root or solve by the square root method. So let's go back to this plus or minus. What does that even mean? Well, what it means is there's 2 answers to this equation, a positive 4 and a negative 4. So when you see plus or minus 4, another way to write that is with 2 answers, x equals 4 and x equals negative 4. That seems weird, so I'm going to show you some comforting facts of how I know that's true. As you know, you can always check your answers from equations by plugging back into the original equation. So one of our answers was x equals 4. If I plug x equals 4 into this equation, I eventually get a true statement that makes me happy. I know x equals 4 is a good answer. But remember, the answer we got was plus or minus 4, which we said means x equals positive 4 and x equals negative 4. Actually, 2 answers in one. So let's check out this one. If I take a negative 4 and plug it in, negative 4, once I square it, is positive 16. 16 minus 5 is 11. Holy cow, that worked, and so did that. So when we get this plus or minus, you can trust that it really is a true thing and that the math is going to work out. One of the tough parts for you is going to be, don't forget that plus minus. Because when you square root inside an equation, you do need that plus or minus. And by the way, hopefully that's not too surprising to you, because we've been working on solving quadratics for a while. And in almost every quadratic situation, we get 2 answers, 2 different values for x. And one thing we've mentioned before, when the largest exponent in your equation is 2, it's very likely that you're going to get 2 answers to that equation. So this thing, or this, should not be all that surprising. So you've noticed that square rooting is going to be a big part of solving by square roots. No surprise, huh? So this would be a good time to remind you that you should have kind of a mental list of certain numbers and their squares. For example, 7 squared is 49. And you can do that list in reverse. These numbers, when you square root them, end up giving you these integers on the left. For example, the square root of 25 is 5. I don't have to do that plus minus when I'm just thinking about the square roots. But when I square root in an equation, then I need the plus minus. So of course your calculator can always help you with this, but the more they're on the front of your brain, the faster and the easier the solving equations is going to be. Okay, 3 more at a rapid pace. Here's the original equation. My goal is to get the x squared by itself, so I get rid of the minus 3 by adding 3. Then I have to get rid of this 3, which is attached by multiplication. So I end up dividing each side by 3, and I get x squared equals 25. Now that I have x squared by itself, I square root both sides, square root the left, square root the right. Hey, I didn't forget the plus or minus 5, or x equals 5, x equals negative 5. You'll notice that all the steps I did right here, I was following these 3 bullet points: x squared by itself, square root both sides, and don't forget the plus minus. Holy cow, look at this new problem. All right, well, this one's kind of an unusual case. When I have my x within a parentheses, I'm not going to get the x squared by itself. I'm going to get the parentheses squared by itself. So in this case, it's already by itself. Well, if I think about how to defeat the squared, it's the square root. And whatever I do to the left, I have to do to the right. So you know on the right, I should get a plus or minus 7 because I'm square rooting inside an equation. And over here, when I square root something squared, the square root and the squared fight to the death. So I get x minus 3 equals plus or minus 7. All right, well, we have another unusual thing happening here. We have x minus 3 equals plus or minus 7. We have not solved this equation yet. We don't have x by itself. What I have to do is move this minus 3 to the other side, but I still have that awkward plus or minus 7. So what I'm going to do, almost any time I have a plus or minus, this strategy is going to work out if I do something like this. Just use the plus 7 for a second. X minus 3 equals positive 7. Write that down. Now focus on the minus. X minus 3 equals negative 7. Write that down. Now I have 2 very simple equations to solve, and I get my 2 answers. And by the way, if you ever wonder if these answers are correct, take the 10, plug it in. 10 minus 3 is 7. 7 squared is 49. That makes me happy. Take the negative 4 and plug it in. Negative 4 minus 3 is negative 7. Negative 7, when I square it, is positive 49. That makes me happy. Okay, we're going to end on this one. And this one looks like a snarly mess. And I just want to remind you that if you felt like it, you could solve this one by graphing. To solve something by graphing, you have to make sure that it's set equal to 0. So I move the 25 over to that side. That's how I get a minus 9. Everything else stayed the same. Now then, I just thought about this as a y equals equation. Put it into Desmos and graphed it, and found the intercepts of x equals 1 and x equals negative 9. So we could solve that by graphing, but I'm going to show you that sometimes you might notice a different way to do it, and that's what we're going to see in this case. So now that I take a look at this equation and I decide I don't want to do it by factoring or by graphing because I see a neat, nifty way, here's what might happen. I might look at this and say, hey, this part over here, I can factor that. These 2 numbers, positive 4 and positive 4, multiply to 16 and add to 8, which allows me to take this and write it like that. This thing can be rewritten like that because it's something times itself. Now I have a squared parentheses, so I can square root both sides. And when I do that, I have to remember the plus or minus 5. Now I can take x plus 4 equals positive 5 and solve it. I can take x plus 4 equals negative 5 and solve it. So I get the same answers through a very weird way as I did with the graphing method. If what we did here at the end is confusing to you, don't let it distract you from the more basic style problems that we do up here, because these are going to be 95 to 99% of any types of square root solving problems you see. That's it.